All right, quadratics part 2. I'm going to start out with another example. Looking at my equation already, I know that it opens up because my number in front of x squared is positive. So it's going to be another minimum value. My vertex, I need to use the formula x equals the opposite of b, which is positive 2, divided by 2a. So 2 times 3 is 6. And that ends up being 1/3. So my x value of my vertex is 1/3. To get my y value, I am going to plug in, so 3 times 1/3 squared, make sure you do that right in your calculator, minus 2 times 1/3 minus 8. And if I do all of that in my calculator right now, I end up with -8 and 1/3. Okay? So you should pause it and make sure you could actually get that in your calculator. So my vertex is 1/3, -8 and 1/3. Let's graph that. 1/3, I'm approximating where 1/3 would be. -8 and 1/3, that's approximately right there. So that is my vertex. My axis of symmetry, it's always x equals, and whatever my x value is, in this case, x equals 1/3. I'm going to use a different color here. So my axis of symmetry is this imaginary line that goes through my vertex. And remember, that'll be helpful when I am graphing my points. My y-intercept, that is pretty easy. That is going to be 0, -8. Now, it's not going to help me a whole lot because it is really close to my vertex, but I know that there's another point over here somewhere because it is symmetric. And now to find my x-intercepts. I know that this one is factorable, and one way that I know that is I kind of do my diamond problem in my head. 3 times -8 is -24, and my middle term is -2. And I could multiply -6 times +4 to get -24, and when I add them I get -2. So as long as I can do my diamond problem and get my two side numbers, then I know it's factorable. If it wasn't factorable, or if I didn't feel like doing it this way, I could just use the quadratic formula. So that is always an option for you. Okay, so factoring, my first term is 3x squared. My last term is -8. And my two side terms, don't forget it would be -6x and 4x. Greatest common factor of my top row is 3x, and 3x times x is 3x squared. 3x times -2 is -6x. X times 4 is 4x, and 4 times -2 is -8. So factoring gives me x minus 2 times 3x plus 4. Since it was my x-intercept, my y value was 0, remember? So my two answers for my x-intercepts would be x equals 2 and x equals -4/3. So remember, for the second one here, I actually set 3x plus 4 equal to 0 and solved it for x, and that's where I got -4/3. So my x-intercepts would be 2, 0. And I'm going to change that to a mixed number so it's easier to graph, and that's going to be -1 and 1/3, 0. So I'll go back to my red marker here. 2, 0, there's one x-intercept, and -1 and 1/3, there's my other x-intercept. And you can see my parabola this time is going to be pretty skinny. If I wanted to find another point to help me out, maybe I will plug in 3. So I'm going to do 3 times 9, since 3 squared is 9, minus 6, since 2 times 3 is 6, minus 8, and I get 13. Now that's not going to quite fit on my graph, but I can approximate that it would be like way up here. And so then there's another point the same distance across. So it's going to be about right here. So that just gives me a good idea. Now if I go to do my parabola, there is my parabola. Okay? All right, let's see. I don't know why this happens sometimes, but I'm probably going to lose everything on this page, but you can always pause it and move on if you would like. Okay, another example. I wanted to do this one for two reasons. Number one, so far all of them have opened up. This one is going to be opening down, and I know that because the number in front of x is negative. So that one's going to be opening down, which means my vertex is going to be a maximum value. Okay? To get my vertex, x equals the opposite of b, which would be positive 4, divided by 2a, which would be negative 2. So my x value is negative 2. The y value, when I plug in negative 2 into my equation, I'm going to get 12. And so I did negative 2 squared minus 4 times negative 2 plus 8. Be careful here. It's actually going to be negative 4 when you're done. And when I do that, I got 12. Now that doesn't really fit. I'm going to make it fit though. So negative 2, 12 is about right up here. My axis of symmetry is x equals whatever the x value is. And I am just going to use a different color. And I'm just have a dotted line. Whoops. That goes through where x is equal to negative 2. So that is my axis of symmetry. My y-intercept. Y-intercept is going to be the point 0, 8, which is right here. And look, if I go 2 spaces to the left of my axis of symmetry, now I have another point over there. So that gives me some good information. And now the x-intercepts. If I tried to do my little diamond problem, I would have negative 8 at the top, because negative 1 times 8 is negative 8, and negative 4 at the bottom. There is not any way that I could get two numbers that multiply to get negative 8 and add to get negative 4. So I am not going to be able to factor this one. So I do have to use the quadratic formula. So using my quadratic formula, x equals the opposite of b, which is 4, plus or minus square root of, the opposite of b plus or minus the square root of 4 squared minus 4 times negative 1 times 8. All of that is over 2 times negative 1. Okay, now I'm going to get out my calculator and do the inside there. So 16 minus 4 times negative 1 times 8 gives me 48. So far I've got 4 plus or minus the square root of 48 all over negative 2. The square root of 48 happens to be 6.93. So my two answers are going to be 4 plus 6.93 divided by negative 2 and 4 minus 6.93 divided by negative 2. So doing that on my calculator, 4 plus 6.93, 4 plus 6.93 equals, divided by negative 2, one of my x-intercepts is negative 5.47, and my other one, 4 minus 6.93 equals, divided by negative 2, is 1.47. So those are my x-intercepts. Negative, I made my points too small here. Negative 5.4 set, let's just make it 5.50 and 1.50. So graphing those 2 points, negative 5.50 is about right there, and 1.5 is about right here. Oops, that was not 1.5, that was just 0.5. And you know, I knew that I messed up because looking at my axis of symmetry, it didn't quite look like it was the same distance here. Okay, so now I know that my parabola is opening down. I've got my vertex, I've got my x-intercepts, I found my y-intercept, which also gave me this other point without having to do any math. Whoops, that was not very good there. Let's see if I can delete that. hopefully. Yay, okay, so let's start over again on my graph here. I have to worry about my shadow. So my parabola, I am not doing so hot, but you would do better. So there's my parabola. Remember, it is a curve, it's not a V, so that would be that equation. I think I am going to stop this at this point as well. I am. So I'm going to stop here, save this recording since it's about 10 minutes long, and then you will need to go on to Quadratics Part 3.